Hi there, Jorge Maia here, and we will talk about IoT Edge, overview and case study for smart buildings. We will talk briefly about the IoT environment on Azure. Let me introduce myself a little bit. I work with IoT since 2014. In Brazil, we have a company here, the Crazy Tech Labs. I'm the principal architect, and we are doing some great projects on retail, on factory, connecting factories, smart buildings, helping buildings and engineering companies to leverage the idea of connecting legacy buildings and outdated to a new one and helping them to become smart. So let's start with our agenda. We will talk about the IoT and Azure IoT platform, Azure IoT Edge, a little bit briefly about that and how can we use it. Smart buildings, what is smart buildings, what we have to do when we talk about smart business and connected business on this vertical. And at the end, I will present to you two business cases that we have working this in last 3 years maybe. Okay, so to start, what is the Internet of Things? Internet of Things, this term coined by Kevin Ashton in 1999, but it's not new. It's not a brand new term that we have. Okay, now I want to start talking and working with IoT. No, IoT is a big umbrella that we can have beside it and inside it some technologies, some communication technologies, some cloud technologies, software, hardware, devices, and many others. I agree with this short definition. We have talking a lot with some clients about the devices interfacing real world, connected through the internet to the cloud. So using the internet to archive more on the cloud. And this is a good idea when we talk about IoT, because we can do some on the edge, we can do some in the middle in the internet by using fog computing, for example, on the borders. But most of processment and AI and data generation we only can do in the cloud. That's the main idea behind the scenes when we talk about IoT. IoT is not just a device connected. It's not just, oh, let me pick up a LoRaWAN, for example, sensor and put it on a building and send it to the cloud. No, it's not the idea. We have to manage this device. We have tons of challenges when we talk about IoT. So the main idea is we need to have device, we need to have the communication, and we need to have cloud. Cloud we can understand as a public cloud or a private one. It doesn't matter. The idea here is what I will have to do to take the data from this device, to take actions with this data, and to come again to the field and do some actions on the field. Maybe an alarm, maybe unlock a door, maybe stop a convey on a factory. Doesn't matter, but you have to do this. And you can't do this without cloud. And when we talk about private and public clouds, the main idea behind it is how can I do it with less effort. That's the main idea. We do not have to develop all this stuff. We can use some pre-built services, some services that are already on the market that we already have a benchmark for it. That's the main idea, and that's the best part of it. And when we talk about data, data comes from sensors, from images, from sounds, from videos, multiple field sources like systems, PLC systems, OPC UA servers, OCR, legacy systems, text, and many others. So web applications, mobile applications on the fields. You can do some good stuff to acquire data from this real world, like a QR code, for example. We have some clients here that they are using QR codes on the buildings to users. Send a notification, for example, I need to clean this room, and they scan a QR code, and it works very well. So it's a manner way of send data to the cloud, to the systems, and take actions to send a message, for example, to the people to clean the room. ERPs, APIs from weather, finance, co-sell, whatever. And other, of course, other streaming, other data that comes, the idea of big data, and all this together, and we can just plug the IoT on it. That's one of the ideas when we talk about data and the Internet of Things. And the flow of this data and the processing of this data, we can do it in three parts. We can do it on the field using just an edge device, for example, or a smart device, or a small server, and we can say that the name of this guy is an edge server or an edge device. We can say, oh, I will process just a little bit inside a dump device. This device will only pick up some data from a sensor and just a small processing to translate a protocol or a small part of this and send it to the cloud. We can do it. We can do it on the internet. We can do it using the fog computing. The idea here is some device that we can put on the middle of the communication between the field and the cloud. And on this device, I can serve many clients of many business, just more near the other devices. So I can use for the same purpose, like translate a protocol, process something, identify some devices, send firmwares like a CDN, a pop-on CDM, for example. So, and I can use the internet, of course, just to communicate, just to link these dots on that. And the cloud. And when I have fields sending data through the internet to the cloud will centralize data and the processing of this data and will do the governance. So define who device is still active, who will be deleted from the systems, who will have not authorized anymore to send messages. I can do user connectors like flows to workflows to send data, to create some information on the business units, to create interfaces like a web apps, like a mobile apps, like a dashboards, and we can have this coming from the field or from the edge. You can name it as better as you want, and passing through the internet and arriving in the cloud to make a big processing, to create some inference APIs to AI and send these frameworks and these modules to the field to run on the field it more faster than if I have to send the data to the cloud, and on the field I have to change this. An IoT solution for smart buildings. When we talk about smart business, we have some concerns that I have on other IoT solutions, like data volume generated, latency, real-time actions. Sometimes I don't need to wait for an internet connection. For example, I have to take an action, like an elevator is stopped, so I have to put it in operation again. I don't have to wait to send it to the cloud to process over there, to return an information, to return an action, to return a command, and to serve the elevator to the public again, to the clients again. It doesn't make sense for us. Latency may be in some cases is a problem. So I have alarms, for example, in zones that I have danger to the users. Only authorized personnel can get in some areas of the building. So I can't wait for a message that comes from the cloud to say to play an alarm or something like this. Okay, security and privacy. Maybe sometimes it should be on the edge, on the field, and we have big problems if a data can I have a data breach, for example, on the data of a building. Who were in the building? Pictures of this people. It can be a mess if I have a breach on that. Costs. I can't send some information all the time to the cloud. If I have a video streaming, I can't send it to the cloud all the time. I have to process on the edge. And sometimes I can't use a public service, for example, because the costs is too elevated. So I have to create by myself some services to run on these buildings. And the data consistency and trust. I need trust on the data. I will take actions based on the data. So when we talk about smart buildings, sometimes we talk about, if I do something wrong, nobody more will get in the building. The people can't turn on the lights, for example. The people can't change the temperature of the air conditioning, and it should create big problems. Here we have an edge architecture overview. It's an idea of a big architecture that we have here on Crazy Tech Labs by a reference one. So we have an edge computing device. Sometimes it is a gateway, sometimes it is a server, like a Dell, for example, or an HP or others. We have some appliances focused on IoT that I have several communications ways and protocols, GSM, 4G, and others. LoRaWAN, for example, Sigfox already connected, and I can use it for to monitor the device, to send the data to the cloud, and I have some good appliances on the market focused on IoT edge. Okay, and when I talk about field, the idea is I have to connect everything that I have in the building on this edge compute solution. So I will need to translate protocols on that. I will need to acquire data from several brownfield devices, so old devices that sometimes I have to connect to them by RS-485, for example, to Wi-Fi protocol specific, and I have to translate that and acquire this data and communicate to this device and make it secure for our application. So I have to trust on the information that comes from this guy, and I have to take it all together and compute it, have have this ready to send it to the cloud, to provide a dashboard like this one, for example, where I'm combining some APIs, external APIs, a weather, for example, and I say, oh, the weather is good. I have 68 outside of the building, 68 degrees, and inside the building, I have a good temperature, and I do not have to increase the flow of the air. So that's the idea. The idea is I have to join all this data and take some actions, and I have to prove this, and I have to show this to the facility manager, for example. Okay, and this is the main idea when we talk about an edge architecture to a solution for a smart building. When we talk about Azure, and we are using Azure in most of our clients, I can say 99% of our clients, we are using Azure to run the IoT solutions. We have a good environment. We have some platform as a service solutions and some software as a service solutions. On software as a service, we have now on IoT Central, for example, a cost per year for device to send the data, and I don't have to develop anything else. It's just to connect the device, and I can use the IoT Central platform, the IoT Central service, to provide me data, to provide me information about the device, to control and manage the device, and to take actions based on this data. And I don't have to create any other resource on Azure. And this is a good one to you start. Sometimes we use it to start a POC, for example. And then if we need, if our solution requires a level that we understand that platform as a service is better, we move the solution to a platform as a service. But in some cases, so the idea of use an IoT Central is a good one because I have just one cost per device. So it's good. And when we talk about the platform as a service solution, I have several resources, services on Azure, like the IoT Hub, the Azure IoT Edge. That's the main actor of all that I'm talking to you here on this presentation. I also can use the IoT Edge connected to the IoT Central. So it's a good idea. Now we can do it. In the past we can't. Now we can do it. We have Azure Functions. Azure Functions is a good glue to connect the dots, to connect the IoT Hub and process this data and send it to a database, for example. We have the Azure Time Series Insight, processing data, acquiring data, creating this data in a time series model, and leaving me to decide that I want to just store the data on a storage account, or I want to use a software development kit to provide dashboards using the time series insight. There is a one solution that fits to many cases, to ingest, to process, and to present the data. So we have good services. Azure Maps. Azure Maps is just connect it to the data from, for example, time series insights, or connect the data using the digital twins that I have layers and metadata from the device, and I can see the special presentation for this device in the building. For example, I have 3 sensors inside a room. I can generate a model of this twin and have this room, and I can aggregate all the data of this guy. And I don't have too much work to do this. I just use the metadata and use the digital twins. So we have a good environment inside Azure to use our IoT solution, to host our IoT solution, and to accelerate the development of our IoT solution. So you should take a look on that. Here I have an expanded edge computing architecture that I showed before, but here I have named to the services, and I will explain a little bit of this. We are using this in most of our clients here for smart buildings. So we have HVAC centrals. We have some data collectors, some cameras, devices, many of sensors on the building, and all of them is connected to the IoT edge or via Ethernet for the IP devices, or via other ones like RS485, RS232, serial, and that depends on the case. Inside the IoT edge, I have some modules. One module of an Azure function running to filter the data. Sometimes we have data coming in binary, sometimes we have data coming in a different form, and sometimes I have to change it to become JSON, for example, to send it to the cloud. So we have a storage module. The idea on the storage module is to sync it. You can see on the right side that I have a storage sync, and I sync the data from the storage. I have also a machine learning inside the edge computing just to do the inference. We are using this right now in cameras and in sensors on this use case on the smart buildings. Okay, we have a Python module in some to provide the calculations and others that we sometimes need, and in some cases we have a web app on the edge. Why I should have a web app on the edge? Because in some places the internet connectivity is not reliable, and we need to take actions on the edge. So, okay, the IoT edge can do it for me, no problem. But why you put a web app on the edge? Because I provide the same application that I have on the cloud on the edge. So I don't have internet connection, no problem. The manager of the facility can see all the data, and I have all the data inside the edge, and then I send it to the cloud. The only difference is I only have a few hours of data. I have, for example, morning. I have afternoon. I don't have the whole day. It doesn't matter for the facility manager. He wants to know the near real-time information. So we do it using a special dashboard on the edge. Okay? Then in the cloud, I have an IoT hub. The IoT hub will manage all the devices and the DPS connected to it will manage the authentication of this device. Okay, the first authentication during the deploy of the device, and then I can manage who can get in the solution or not. talking about hardware. Okay, we have the IoT hub connected to the digital twins. The digital twins is connected to a web app on the cloud side, and a time series insight to acquire all data coming from the IoT hub and send it to a storage account that I can manage the data. I can acquire data from this storage account. The time series insight will save a Parquet format on that, so I can use the machine learning studio and can create my machine learning services to send it as a container module using the container registry to the IoT edge. Okay, all of that is managed by a key vault, and I have, of course, a service bus connected to legacy systems. In many cases, we need to have that, and a logic app sometimes doing the workflows of communication, alarms, and others. Okay, I'm trying to talk briefly about that. If you need more information, let me know. Send me an email or a private message, a direct message on Twitter or on LinkedIn. It will be a pleasure to discuss more about that with you. Okay? And when we talk about the smart buildings, what is smart buildings? Smart buildings, in our conception here, is the idea of collect all the data and manage and create an easy way to manage the facility. That's the idea, to manage the whole building. Since from the electricity measurement, gas, water, and take all this data and give one way to manage the whole building. To say, oh, you can decrease the use of electricity in 60th floor, for example. Okay, that's the idea behind that. So when we talk about that, we have HVAC. That's one of the components of a building, and we have to acquire data from that. We have to take actions on that. So this is one of the guys that we take too much time to put it inside an IoT edge solution. Electricity management and consumption, it's another point that we have to take the eyes on that and manage that and understand the patterns of use of that from user's perspective, from the floor perspective, to detect anomalies on that. That's not easy, but we have tools to do that today. We have tools like machine learning, and we can use historic data to provide it. Okay? We have the access control. I can't leave the building and left some floors with power on, for example. There is nobody on the floor. Why the lights are turned on? And that's the question that we can answer if we have the data from access control, if we have the data from the power consumption by circuits, for example, and if we can take some actions on that. I can't, it doesn't matter if you say, oh, okay, the lights are turned on. Send someone to turn it off. It doesn't matter. The idea is you have to turn it off. And you can do it because many of the buildings already have control on it. It's just connect the things. You have automation on that, but you have to connect to the automation center, okay? And the other thing is internal transportation, stairs, elevators. Why they are using too much on Sunday, for example? Those are questions that we can answer. the elevators, stairs, lights, power consumption, water. Why? Why we have this? What is the pattern of the building? So this is the idea. When you have data to do this, we have tools to do this, and we have connection. Because in some buildings that we worked on, the people have automation. No, we have automation, we have good software to automation, but oh no, it's not connected. And to see what's going on the elevators, we have to extract a report of the software, that the software is standalone on a machine, and we have to connect all this stuff, all this, process this data on the edge, near the device. If I have this, I can take actions on the time of the fact, of the event. And this is the idea, okay? And another thing, that is not a point to monitor, or an item that you can, I can use a sensor, or I can take an action. No, but utilization. I want to schedule a meeting in the room. If I have this data, if I say, Jorge will use the meeting room on the second floor. Okay, at what time? At 2:30 p.m. So I can turn on the air conditioning and the ventilation at 2:15, and I have 15 minutes to put it on a good temperature. I just have to turn on the lights when the people get in on the room. It's not before. We have some buildings here that the people, we turn on the lights of the floor at 2 p.m. and then we turn off at 7:30. And if someone are on the floor, we leave all the floor with the lights on. And this is not good. We will pay more on the bill, okay? And this is an information that we can use it to send it to a Teams or Microsoft Teams, for example. And it's a good thing. We done this to a client here. On average, people spend 80% of their lives inside buildings, offices, schools, hospitals, and homes. So we need a thing like user experience on this building. Man, imagine if I can get in on a building and I have an app that can say me, you should turn left, turn right to get the second floor, and then when you get the second floor, you go straight ahead and turn left on the second door, and you were in on the meeting. It's time saved to the user. It's a new experience. We are running a web. It's not a web app, but it's a web page that we done this, and it runs on mobile phones on the buildings. And we acquired the data from sensors on the building. So we can say, you are here, you have to move to this point, so you turn left, and we start using inside maps, so indoor maps. So this is the idea. And with this, we have user experience. The people say, it's good. That's the idea. I will help this to work on. So I will scan a QR code and say, the environment's clean. It's good. I feel safe here on the parking lot. And we are using this to get this feedback from the users. So we know that we have people on the parking lot because we have cameras and we can count the people on the place. And then we have the time, and the people say, I feel safe on that. And it's good. It's clean. I liked the restroom. It was good. And this is the idea when we talk about the buildings. So let me talk briefly about the Engemon IT. Engemon IT is a partner and a client of us. They have a floor in a building here in Brazil, in Sao Paulo. And we had to connect and to control the main floor of the Engemon and the Engemon IT. They are two companies on this space. So we have 200 people working on this space, and we have access control from one company. We have an HVAC from another company. We have electrical information from another company with another protocol, and we have some cameras on the building. From and on these cameras, we are running an AI algorithm to detect people and to say, Jorge is seated on his table, so he's in the office. He's working in his table. Okay, so we are using this. The first phase, we have some results that was expected, and we archived that. So integration of the meeting rooms with Teams. We used that architecture that I told you before, and do the integration with Microsoft Teams. We do the control of air conditioner, ventilation, and temperature based on the room occupancy. So is there some people in the room? No. So we don't have to turn on the ventilation. We can turn off. We don't have to. So that's the idea. We also decrease the waste on electricity consumption based on room occupancy. Turn off the lights. That's one of the things that we done. Help the facility manager with the restroom cleaning. That was an idea from this client and from the other one that I will talk after this. And everybody is looking for this because people is costs. We have people running on the old building trying to clean this. Why? Why we have to take a person to get in a restroom 5 times a day if we are in the middle of a pandemic of the new COVID-19 and there is nobody. There is 5 people, for example. I don't have to get in on the restroom all the time. And now we are doing and running some algorithms to detect and count people inside the places, not only the restrooms, and to say there's people inside it. There's people that comes and lives in 2-3 minutes maybe. We don't have to take take the people to clean that space. We do not have occupancy on that. And the second case is the Orion Group. Orion Group is an engineering company that sells services of smart buildings to another clients. And this is a big challenge because they have different environments every time. It's not easy to say, we can use this device, this protocol. No, we had to create something that is brand new at every case, and it should be scalable, and it should be easy to develop because they need to do POCs, pilots. They have to sell solutions that they can implement in a few weeks. For example, it's just the time to buy the sensors, the devices, the edge services, the edge servers, sorry. And we have multiple environments, metering devices, protocols, communication problems. Because sometimes we have Ethernet, sometimes we need to use 4G, sometimes we are on underground, have old buildings. We can't use cables on old buildings. That we will have to do a lot of workarounds to do this, and this should be a problem. And if I want to use a radio frequency, for example, maybe I have problems because old buildings, too many mirrors in the middle, so glass, and this can be a mess. Integration with edge solutions pre-owned. We already have some from vendor A, vendor B, vendor C, and we have to do the integration. So we had to develop something on IoT Edge that I can use multiple protocols, and should be simple to the engineering team of the Orion Group to develop that. And high security environments, because they sell solution to government buildings, and it's different. Another compliance, another idea of security, more rules, and it is really a problem. And here we can see some of the real life. So electrical panels. Here, an augmented reality software from the Schneider Electric, and here we can see some markers on the places, and we have information on that. So in some cases we have the client already have that. So if you already have it, okay, let's use it. No problem. We can send more data, for example. We can acquire more data using this on a tablet, for example. Okay. And here we have a simple solution that we are doing using the Gavasi metering, and we send it to, we have here a Modbus gateway, and send it to the edge. And when we have this, we send it to an IoT hub. And on this case, we are using an Azure function to process all the routes of information, because it was easiest to develop and to deploy in multi-tenant solutions and multi-environment solutions. Okay, and here we have some Power BI dashboards. Over there, they want to use the Power BI instead the time series inside for this project, and we export the data to a SQL server, and then of course we exported only the KPIs aggregated to they can see the data on the Power BI dashboards. And here we have the final dashboards that they present, and that they give access to the final clients. And here we have for another building the consumption of the month, the idea of prediction to the next month, and this is the idea of a final product, looking for the electricity consumption, of course. And we have more dashboards and more information and reports and data from the other perspectives of the solutions. So guys, thank you very much for attending this session. Here is my Twitter, my Instagram, and my LinkedIn. Feel free to contact me at any time. So it will be a pleasure to talk with you about this presentation. If you have another question about IoT and the IoT environment on Azure, if I can help, will be a pleasure. Thank you very much. Special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks. Some community, this is a community initiative, and some community initiatives from these groups: the SQL Server Geeks, the Data Platform Summit, and the Data Platform Geeks. There is 3 ways for you to win prizes on this event. You can post yourself with a hashtag DPS 2020. You can give a session and a conference feedback. Please do it for us. It's good for the speaker, if it's good for the event. And you can visit our sponsors and our exhibitors. Don't leave the event without do this. You should have a good stuff on the sponsors and exhibitors. And follow the event on the Twitter, the Data Geeks and Data AI Summit. Thank you. very much for your time.